Welcome students. Today we will solve fifth problem on trusses. We will solve it by method of joints. So let us start today's lecture. So we are given one truss over here and we are asked to find forces in all the members of this truss by using method of joints. Now we know whenever we have to solve any problem on trusses, the very first step is we should identify the supports given in that truss. So in this truss, we are given two supports. One is at joint B and second is at joint D. This is a pin support and this is a roller support. We know pin support provides two reactions. One normal to its surface and second along its surface. So this is the surface shown. So to this surface, this will be normal reaction and this will be along its surface. Now the second support over here is a roller support and this is the surface of roller support, and we know roller support provides only one reaction normal to its surface. So now let us show these reactions on these two supports. So let us start with the pin support first. So we have shown one normal reaction and we have labeled it as Rbx, that is reaction at B in x direction. Though it is normal to the surface of pin support, but it is acting in x direction for this problem, so that's why we have labeled it as Rbx. Now let us show the second reaction, and we have shown this reaction along the surface of this pin support and we have labeled it as Rby, means reaction at B in y direction. Now we know that at the start we don't know the direction of these reactions, so we have just assumed their direction. So for Rbx we have assumed its direction towards right. For Rby we have assumed its direction in downward direction. Okay, now let us place the reactions provided by support placed at joint D, that is roller support, and we know it provides only one reaction, that is normal to its surface. And we have labeled it as Rdx. The meaning of that is reaction at D in x direction. And for this reaction also we don't know its direction at the start, so we have just assumed that it is acting towards right. So the very first step is identify the supports given in the truss, then label the reactions provided by that support. So the first step is identify the supports given in the question and label the reactions provided by those supports. Now what is the next step? Next step is that we should find these three unknowns. So we can find these three reactions with the help of equations of equilibrium, and those equations are summation fx is equal to 0, summation fy equal to 0 and summation m equal to 0. So it means now our next step is we have to find Rbx, Rby and Rdx. So let us apply the first equation, that is summation fx is equal to 0. So before applying this equation, let us first see how many total number of forces are there in this truss. So there are 5 forces, 3 are reactions and 2 are external forces. One is labeled at joint A as 8.4 kN, second is labeled at joint C as 8.4 kN, and both these forces are horizontal forces. Okay, now we have to see how many forces are acting in x direction. So there are 4 forces acting in x direction. One is Rbx, Rdx and these two external forces. Rbx and Rdx both are acting towards right, so we have to consider these two positive, and these two external forces are acting towards left, so we will consider these two negative. It means our equation will be Rbx plus Rdx minus 8.4 equal to 0. In this equation we have two unknowns, so we cannot solve this equation. So let us write this equation as Rbx plus Rdx is equal to 16.8 and let us label this equation as 1 for time being. Now let us apply the second equation, that is summation fy equal to 0, and let us see how many forces are acting in y direction. There is only one force, that is Rby, so we will get Rby equal to 0. Now let us apply third equation, that is summation m equal to 0. So let us take the moment about joint B. So we will take moment about joint B, we will get rid of these two forces because these two are intersecting joint B, so their moment about joint B will be 0. It means for this particular equation we have to observe the moments of these three forces. So let us first observe the moment of Rdx about joint B. Now this is the line of action of Rdx and this is the moment center. So between these two, this is the perpendicular distance and it is 4.5 meters. And this Rdx will generate anti-clockwise moment. So it means it is a positive moment. So moment because of Rdx will be written as positive Rdx into 4.5. Now let us observe the moment because of this external force. Now this is the line of action of 8.4 kN force acting at joint A and this is the moment center. The distance between the line of action of the force and the moment center, that is perpendicular distance, it is equal to 4.5. And 8.4 kN will also generate anti-clockwise moment, so we have to consider that as positive. So moment because of this force will be positive 8.4 into 4.5. Next we will see moment because of this particular force. Now the moment because of this force will be equal to 0. Why? Because this force intersects the moment center. So perpendicular distance between the line of action of the force and moment center will be 0. So moment because of this force is equal to 0. So final equation will be Rdx into 4.5 plus 8.4 into 4.5 equal to 0. So from here we will get value of Rdx. So over here we are getting negative value, that is minus 8.4 kilonewton. So what is the meaning of minus sign over here? It tells us that the direction which we have assumed at the start for Rdx, it is not correct. So it is not acting towards right, actually it is acting towards left. So for next calculations, when we have to consider Rdx, we have to consider this correct direction. Now next we have to find value of Rbx. So for that what we have to do? We have to put value of Rdx as minus 8.4 in equation 1 to get value of Rbx. So the value of Rbx is 25.2 kilonewton and it is a positive value. That means whatever direction we have assumed at the start for Rbx, that is correct. So it is acting towards right. So we have concluded that Rby is 0, Rbx is 25.2 kilonewtons and Rdx is acting towards left and its magnitude is 8.4 kilonewtons. So let us correct these reactions. So we have replaced notation Rbx by its magnitude, that is 25.2, and we have reversed the direction of Rdx. We have shown now towards left and we have labeled its magnitude as well, and we have eliminated Rby. Okay, so now what is the next step? Next step is that we have to find the forces in these 5 members of the truss. And we know if we want to find the forces in these members, we have to start with a particular joint. And before starting with the particular joint, we have to first follow rule number 1. What is that rule? That we can start with that joint only at which maximum unknowns are 2. So let us observe joint D. At joint D, we have one reaction and we have calculated the value of that reaction. And to joint D, there are 2 members connected and in these 2 members, forces are unknown to us. So at joint D, maximum unknowns are 2 only. It means we can start with joint D. So let us start with joint D. So in the first step for forces, we will write equilibrium of joint D. Now in order to apply equations of equilibrium for joint D, we have to first construct its free body. So let us construct its free body. So how to construct? First of all, label the joint on our paper. Then we must see how many members are connected to that joint. So to this joint D, there are 2 members connected. One is in vertical direction and second is at some angle to horizontal. So let us show these two members in the free body. So one is a vertical member and second member is at some angle to the horizontal. Now after that we have to show the direction of forces in these two members. We know that if the forces are unknown to us or the members are unknown to us, then in that case we consider tensile forces, means forces acting away from the joint. So in both the members we will represent forces away from the joint, means we will assume their nature as tensile nature. So see, in this member which is DB, we have shown its force acting away from the joint. So this is a tensile force. So this is member DB, so we have labeled its force as FDB. Now this member is DC. So in this member also we will consider tensile force, means we will assume the direction of the force away from the joint. So let us label this force as FDC. Now after this we should see, is there any external force acting at joint D? No, there is no external force acting at joint D. Then we should see, is there any reaction acting at joint D? Yes, there is one reaction, 8.4 kilonewton acting towards left. So at joint D we have to show that reaction. Now after that we have to see, is there any inclined force in the free body? Yes, there is one inclined force in the free body. So we have to resolve that force into its components. So this is the origin of this force. So from this origin we will draw two lines, one along horizontal direction, one along vertical direction. So these two will be the components of this force. Now let us label their directions. So for that we have to see the direction of force. So the direction of force is away from origin. So for these two components also we will show their direction away from origin. Away from origin. Now let us label the magnitudes of these two components. So for that we have to first locate the angle of this force with any of these two components. So let us locate the angle of this force with this vertical component and let us call that angle as theta. So let us see where this theta exists in the truss. This theta is over here. So let us find this theta. So for that we have to consider this triangle, this right angle triangle DBC. So we will say in right angle triangle DBC, tan theta is equal to perpendicular upon base. That means 2.8 divided by 4.5 is equal to tan theta. Or we can say theta is equal to tan inverse of 2.8 divided by 4.5. So when we will calculate this, we will get theta as 31.89. So we have found theta now, so we can label these two components. So we are considering the angle of this force with the vertical component. So this component will be cos component and other component will be sine component. So we will label it as FDC cos 31.89 and we will label this component as FDC sine 31.89. Now we are ready with the free body of joint D. So let us apply equations of equilibrium. Let us start with the first equation, that is summation Fx is equal to 0. So how many forces are there acting in x direction in this particular free body? There are two forces. FDC sine 31.89, it is acting towards right, so we'll consider this as positive. Then we have 8.4 acting towards left, we will consider this as negative. So equation will be FDC sine 31.89 minus 8.4 equal to 0. So from here we'll get the value of FDC as 15.9 kilonewtons. Now see, we got positive value for this force. So that means whatever direction we have assumed for that force at the start, that direction is correct. And we had assumed tensile force, means away from the joint. It means FDC is a tensile force. So next to the magnitude we have labeled letter T. So T stands for tensile force. Now after this we will apply second equation, that is summation Fy equal to 0. So let us see how many forces are acting in y direction. There are two forces. One is FDB it is acting in upward direction, so we will consider this as positive. Second is FDC cos 31.89 and it is also acting in upward direction, so we will consider this also positive. It means our equation will be FDC cos 31.89 plus FDB equal to 0. We have found the value of FDC in the above equation and it is 15.9. So let us put that value in this equation and we can get value of FDB. So value of FDB is equal to minus 13.5. So this is a negative value. So what this negative sign tells us, it says that whatever direction we have considered for FDB at the start, that is not correct. So we have to reverse that direction. At the start we considered direction away from the joint, means we considered FDB as a tensile force, but we got negative answer. It means FDB is not a tensile force, it is a compressive force. So next to this answer we have written letter C. So C stands for compressive force. So from these two equations we found FDC. So FDC is a tensile force, so it is acting away from joint D. But FDB is a compressive force, so it is acting towards joint D. Now, what is the next step? Next step is, after solving a particular joint, we have to pick next immediate joint. The next immediate joint to D are joint C and joint B. So we can start with any of these two joints. So let us start with joint B. So now we will say equilibrium of joint B. So in order to apply equations of equilibrium for joint B, first of all we have to make its free body. So in order to make the free body of joint B, first of all we will represent that joint on the paper. Then we will see how many members are connected to that joint. So to joint B there are three members connected. One is horizontal, one is vertical and one is at some angle to the horizontal. So let us show these three members. So we have shown one horizontal member, second is at some angle to the horizontal and third is vertical. Now after that we have to label the direction of forces in these three members. Now we will start with the known member first. So out of these three members, member DB is known member to us because for this member we have already calculated its force. And that force is acting towards joint B. That means this force pulls joint B in downward direction. So joint B will provide equal and opposite reaction in upward direction. So that means for joint B we have to consider this direction of the force in member DB. So see over here. So it is acting towards joint B. So this is a very important step. There should not be any confusion over here. So we have already found its magnitude, it is 13.5. Now after that we have two other members and these are unknown members. We don't know the forces in these two members. So what we will do for these two members, we will consider tensile force. Means we will label the direction of the force away from the joint. So this is member BC. So in this member we have labeled a tensile force away from joint and that force is FBC. Another member connected to joint B is BA and this is also an unknown member. So in this member we will again consider tensile force that is acting away from the joint and let us label it as FBA. Now after this we should see, is there any external force acting at joint B? No, there is no external force acting at joint B. Then we will see, is there any reaction acting at joint B? Yes, there is one reaction of 25.2 acting at joint B towards right. So let us show that reaction. Now after that we will see, is there any inclined force acting in the free body? Yes, there is one inclined force acting in the free body. So next step is we should resolve that force into its components. So for this force, this is the origin. From this origin we will draw two lines, one along horizontal and one along vertical. So these two will be the components of this force. Now let us label the directions of these two components. For that we have to see the direction of force first. Now the direction of force is away from origin. So in these two components also we have to show direction away from origin. Direction away from origin. Now let us find the magnitudes of these two components. So for that we have to first locate the angle of this force with any of these two components. So let us locate its angle with the horizontal component and let us call that angle as theta. So let us see where is this theta in the truss. So this theta is over here. So this is theta. So in order to find this theta, we can consider this right angle triangle BCA. So in right angle triangle BCA, we will say tan theta equal to perpendicular upon base. That means 4.5 divided by 2.8 is equal to tan theta, or theta will be equal to tan inverse of 4.5 divided by 2.8. So from here we will get value of theta as 58.10. So now we can find the magnitudes of these two components. So we have considered the angle of this force with horizontal component. So this will be cos component, other will be sin component. So let us label these two components. So it will be FBA cos 58.10. This will be FBA sin 58.10. So now we are ready with the free body of joint B. So let us apply equations of equilibrium. Let us start with the first equation, that is summation Fx is equal to 0. How many forces are acting in x direction? So there are three forces. 25.2 acting towards right positive, FBC acting towards right positive, FBA cos 58.10 acting towards right positive. So equation will be FBA cos 58.10 plus FBC plus 25.2 equal to 0. So in this equation we have two unknowns. So we cannot solve it. Let us call this equation as equation 1 for time being. Now let us apply the second equation, that is summation Fy equal to 0. So how many forces are acting in y direction? 2. FDB, which is 13.5 acting in our direction, it will be positive. Then FBA sin 58.10 acting in our direction, it will also be positive. So equation will be FBA sin 58.10 plus 13.5 equal to 0. So from here we will get value of FBA as minus 15.90. So negative sign over here tells us that the direction which we assumed for FBA at the start is not correct. At the start we have assumed tensile force, so we got negative answer. It means it is not a tensile force, it is compressive force and it is acting towards joint. So see over here, next to the magnitude we have written letter C. C stands for compressive force. Now once we get value of FBA, now we will put this value in equation number 1 to get value of FBC. So we will say put value of FBA in equation 1. So that is minus 15.90. So we have entered that value in equation 1. So from here now we can find value of FBC. So FBC will be minus 16.79. So again we got negative answer. That means FBC is also a compressive force because initially we considered it as away from joint as tensile force, but we got negative sign over here, so we will say it is not a tensile force, it is acting towards joint, so it is a compressive force. So from these two equations we have found that FBA is acting towards joint B and it is a compressive force. And FBC is also acting towards joint B and it is also a compressive force. So now we are left with only one unknown, that is FAC. So let us find that unknown. So for that what we need to do? From this joint B which we have solved just now, we have to move to the next immediate joint. So we have two next immediate joints, joint C and joint A. So we can start with any of these two. So let us start with joint A. So we will write equilibrium of joint A. So what is the first step? Draw its free body. That means first of all represent the joint on paper. Then we should see how many members are connected to that joint. There are two members, one is vertical and second is at some angle to horizontal. So let us label these two members in the free body. we will draw one vertical line and one line at some angle to the horizontal. Now after that we have to label the direction of forces in these two members. So we will start with known member first. Out of these two members, FBA is known member because for this member we have calculated its value as 15.9, and this force is acting towards B. So that means it will pull joint A in this direction. So joint A will offer equal and opposite reaction. So this reaction we have to consider in the free body of joint A as active force. See over here. So this is FBA acting towards the joint and its magnitude is 15.9. Then the second member is unknown member for us, and we know for unknown member we consider direction away from joint, means tensile force. So this member is AC, so we have labeled that force as FEC. Then we will see, is there any external force acting at joint A? Yes, there is one external force, that is 8.4 kilonewton. So show that external force over here, and it is acting towards left. Then after that we will see, is there any reaction acting at joint A? No, there is no reaction acting at joint A. Then we will resolve the inclined force in the free body into its two components, one along horizontal direction, one along vertical direction. So let us show those two lines. So these two are representing the components of FBA. Now let us show their direction. So for that we have to see the direction of force first. So force is acting towards origin. So in these two members also we have to show direction towards origin. So direction towards origin. Now let us find the magnitudes of these two components. So for that we have to first locate the angle of this force with any of these two components. So let us locate angle with this vertical component. Let us say it is theta. So where is this theta in the truss? This theta is over here. So in order to find this theta we will say right angle triangle BCA. So in this triangle we will say tan theta. Tan theta will be equal to perpendicular upon base. That means 2.8 divided by 4.5 equal to tan theta, or theta will be equal to tan inverse of 2.8 divided by 4.5. So from here we will get value of theta as 31.89. Okay, so now we can label the magnitudes of these two components. So we have considered the angle of this force with vertical component. So this component will be cos component, other component will be sine component. So we'll label this as 15.9 cos 31.89. So this will be 15.9 sine 31.89. So now we are ready with the free body of joint A also. So let us apply the first equation. Now we can apply two equations over here. We know summation fx is equal to 0 and summation fy equal to 0. But look over here, if we will apply summation fx equal to 0 first, then we will get nothing because both are known values. But if we will apply summation fy equal to 0, then only we can get this unknown value. So we will apply only summation fy equal to 0. So how many forces are acting in y direction? There are two. FAC acting in downward direction, it will be negative. 15.9 cos 31.89, it is acting in upward direction, we will consider this as positive. So equation will be 15.9 cos 31.89 minus FAC equal to 0. So from here we will get a last answer, that is FAC equal to 13.5, and we got positive value for this. That means our assumption for FAC is correct. So our assumption was tensile force. So positive value tells us yes, that assumption is correct. It is actually a tensile force. So we have concluded that force in member AC is tensile force of 13.5 magnitude acting away from the joint. So I hope this particular numerical is clear to you. Thank you very much.